Hello, and welcome to 7.4 Reciprocal Functions. You may have heard this word before. This basically just means flipping it, so the top becomes the bottom and the bottom becomes the top. So this is what we're going to focus on today, these things called vertical asymptotes, where we have values of x that aren't allowed because they cause us to have to divide by 0, which we know from previous units is not good. So here it just says the reciprocal of a number is interchanging the numerator and denominator. Find the reciprocal of each number below. So this one is 4/3. This one is negative 13 because it's negative 13 over 1, and we don't need the 1 in the denominator. And the negative doesn't have to be with any specific one of these two. It's just the whole thing in general is negative. So the reciprocal of 200 is 1/200th. The reciprocal of 1 is 1. The reciprocal of -1 is -1. And the reciprocal of 0, well, your calculator will say error. This is undefined. So let's quickly burn through these. 1 divided by 100 is 0.01. 1 divided by 10 is 0.1. 1 divided by 1 is 1. 1 divided by 0.1 is 10. Divided by 0.01 is 100. Divided by that one is 1,000. So you notice that every time we, as the numbers get smaller and smaller and smaller, the reciprocal of the numbers gets larger and larger and larger. So that's 10,000. This one is 100,000. And this one is undefined. Can't divide by 0. Alright, so do it again for negative ones. Negative 0.01. Negative 0.1. Negative 1. Negative 10. Negative 100. Negative 1,000. Negative 10,000. Negative 100,000. And again, undefined. Can't divide by 0. So, the reciprocals of large positive numbers result in small positive numbers. Reciprocals of large negative numbers result in small negative numbers. So if you divide by something big, you're going to get something small. If you divide by something small, you're going to get something big. So, small positive numbers close to 0 will give you very large positive numbers. And dividing by negative numbers close to 0 will give you very large negative numbers. There are only two numbers whose reciprocals have the same value as they themselves do, and the numbers are 1 and -1. You flip those, you get the exact same thing. The reciprocal of 0 is undefined. Okay, not allowed to divide by 0. So, moving on. Give the ordered pair of the numbers obtained by taking the reciprocal of the y-coordinate. So, we're only going to focus on the y-coordinate and change the y-coordinate to get the reciprocal coordinate. So, all of the x values are going to stay the same. So, this becomes 5 and 1/3. This is -2 and 3 over 1, which is just 3. This is 14. Negative 0.02. If you do that in your calculator, you'll get -5. This one is 0 and -1/10, or 0.1. And this one is -6 and undefined. Can't divide by 0, so we're going to see what consequence there is on a graph. So plot the new coordinate, the new point obtained by taking the reciprocal of the y value of each existing point. So, take each point, find its y value, and flip it to get a new one. So this one right now, doesn't matter what the x value is, but it happens to be at -5, and the y value is +5. So we flip the y value, but leave the x value untouched. So the y value becomes 1 over 5, which is 0.2. So the new point becomes negative 5 and 0.2. This one is at negative 4 and 3, so that becomes negative 4 and 1/3. This one is negative 3 and 2, so that becomes negative 3 and 1/2. This one is negative 2 and 1, and 1 flipped is just 1, so that point's going to be exactly in the same place. This is a half, so negative 1 and positive 1/2. When you flip it, 1 divided by a half, you're going to get 2. This one, let's say, is 1/3, so it's going to put us right there. This one is 0. Can't divide by 0. It gives us something called a vertical asymptote. So that's what happens when it's undefined. We get this. And a vertical asymptote is something that never gets crossed by the graph. So as we come closer and closer and closer to this point that has a y value of 0, the reciprocal function gets closer and closer and closer and closer, but never actually touches that line. Okay, and then you can jump over to the other side and continue with the exact same trend. So this is positive 2 and negative, 1/3. So let's put us at 3. This is positive 3 and 1, so that'll just leave us at 1. This one is positive 4 and negative 3, so that'll put us at 1/3. And this one is positive 5 and negative 5, which will put us at 0.2. So again, we have this kind of curve that goes like this and gets closer and closer and closer to that vertical asymptote, but never actually touches it. Okay, so we have two distinct branches in our graph here. They both approach this line, but neither of them will ever cross it. Sketch the graph of the reciprocal of each function. So this, again, it's about finding the value of the y-coordinates and flipping it. So the value of the y-coordinate here is 4, so it becomes 1/4. The value of the y-coordinate here is 3, so it becomes 1/3. Y-coordinate here is 2, so it becomes 1/2. The y-coordinate here is 1, so it stays 1. Y-coordinate here is 0, so it becomes a vertical asymptote. So again, intercepts are going to be very important in the original functions, because that is where you're going to have a vertical asymptote, because they represent the zeros of the function. And then when you take the reciprocal, you're dividing by 0, which causes the vertical asymptote. So the y value here is negative 1, so the reciprocal is negative 1. The y value here is negative 2, the reciprocal is negative 1/2. The y value here is negative 3, so the reciprocal is negative 1/3. Y value here is negative 4, so the reciprocal is negative 1/4, and it will continue on like that, getting ever closer to the x-axis and getting ever closer to this vertical asymptote the other way, but never crossing it. Okay, so similarly we can work with a parabola in the exact same way. Alright, so working on a quadratic now, we have a parabola. So again, the exact same rules apply. Find the value of the original y-coordinate, flip it. So this one is 6, so it becomes 1/6. Alright, let's skip a few. This y value is 3, so it becomes 1/3, so a little higher, but again on the same x line. This one is 2, so it becomes 1/2. And this one is 1, and it will stay as 1. Now here it's 0. You can't divide by 0, so that will create a vertical asymptote. So we're going to have something that approaches that asymptote but never touches it. And this part is going to look like that. So notice that the vertical asymptote is at the 0 of the original quadratic. So the roots of the quadratic function are going to be important in this unit as well when we're doing reciprocal functions, because they are going to be the locations of your vertical asymptotes. So then what goes on down here? Well, all the y values are negative, and when we flip them, they're going to stay negative. So everything's going to be below the x-axis here. So find a few key points, like this one is negative 1 is the y value, so it will stay. Here, the y value is negative 4, so that becomes negative a quarter. Here the y value is just over negative 6, so that becomes just a little less than negative 1/6. Here it's 4, so that becomes a quarter. Here it's negative 1, so that stays as negative 1. And then here it's 0, the y value is 0, so that creates a vertical asymptote. And so your graph on this side then approaches those vertical asymptotes and curves around like this, but it will never cross those vertical asymptotes. And then again, you do the same thing over here. 1 stays as 1. This one, 6 becomes 1/6. And then you can kind of figure out that the trend is going to continue. But we'll never cross that x-axis. It'll always stay just above, and it will never cross that vertical asymptote either. So we're not going to do this one. This is sort of the reciprocal of a quadratic, just like the one we just did. So you will end up with a quadratic where in this little area, this is just under 1, so it will be just above 1 when it's flipped. Don't know exactly where. And here are your zeros, and it would go right through those zeros there. And your parabola would look something crudely like that, but a little nicer. All right. So I'm going to let you do this warm up on your own based on everything you've just seen. I think you can do it. So go ahead, give it a run, and we can take a look at it later if you have any trouble. Here's a your turn. Go ahead and give this one a run. When you're done, the answer will be here as usual, although I question whether these are even getting done or not, but hey, gotta believe. Gotta believe. I have faith in you. So, give it a try. So there are your answers for this one. And I'm going to, unlock. I'm going to bring it to front so you can see the whole thing. Okay. So there you go. If you factored out a 3, you would get 3 times x minus 3, and that would make it obvious that at positive 3, that's where your 0 is going to be, your vertical asymptote. Here's another one. This is a quadratic, so give it a try. Remember, the vertical asymptotes will occur at the zeros of this function. So factor this, and then find those locations of those vertical asymptotes. And looking at it, I think it's going to be negative 3 and positive 2. Let's verify that. Negative 3 and positive 2. Okay, so there you go. This is the original function, the parabola. And then this with the 2 vertical asymptotes. That's your reciprocal function. Here's another one. Go ahead and give it a try, see if you can make some sense of it. There you go. That's it. See you in class.